Today, we're going to be talking about solubility, or how well things dissolve in water. I think it would be best to jump into the experiment to show you what solubility looks like, and then to explain what's going on once you've seen what it really looks like. For today's experiment, you will need water, vegetable oil, salt, 2 glasses, 2 tablespoons, and a measuring cup. Before we get started, make sure you're following proper safety precautions. This includes tying back long hair and wearing eye protection, gloves, and long sleeves. In 1 glass, pour a tablespoon of salt. Then pour a half a cup of water into the glass and stir until they're mixed completely. In the other glass, pour 1 tablespoon of oil. Then add half a cup of water to the oil and stir. The salt and water are able to be mixed together so that you can't tell one from the other. The word used to describe the solution is homogeneous, which means the solution is blended so that you can't see the two things separately. Since our solution is homogeneous, it means that the salt is dissolved in the water. The oil, however, is heterogeneous in the water, meaning that the oil and water are still separated. They have not mixed, and the oil has not dissolved. No matter how long you keep stirring, the oil will not dissolve. This is because both the salt and oil have their own solubility. Salt is soluble, meaning that it is able to be dissolved in water. Salt is a compound made of 2 ions bonded through an ionic bond. When the salt is placed in water, the 2 ions in the compound separate, meaning that the salt has dissolved. The compound is polar, meaning that it has a positively charged end and a negatively charged end. When the compound interacts with water, the negatively charged oxygens in water attract the positively charged sodium ions in the salt, since opposite charges attract. The positively charged hydrogens in water attract the negatively charged chloride ions in the salt. This causes the sodium and chloride to be split apart. Since the salt is dissolved, we can say that it is the solute, and water is the solvent. A solute is any species that's in a lesser quantity than the solvent, and is dissolved by the solvent. The solvent, water, is in a greater quantity and does the dissolving. However, oil is not able to be dissolved in water, so we say it's insoluble. In the same way that salt is polar, oil is nonpolar. Its molecules do not have any parts that are positive or negatively charged. So, when oil is added to water, there's no attraction that would cause the oil molecules to separate and allow the oil to be dissolved. A second experiment we can do regarding solubility is the concept of saturation. Again, I think it would be helpful to show you the experiment first, then go into the details. For this experiment, you'll need water, salt, a tablespoon, and 3 glasses. First, add a tablespoon of salt to each glass. Then, add 1 tablespoon of water to the first glass. Add 3 tablespoons of water to the second glass. Then, add 5 tablespoons of water to the third glass. Once you're done, stir the solutions. We can see that in the first glass, the salt didn't dissolve, but in the second and third glasses, it did. So what happened? Here we can talk about concentration and saturation. In order for something to be dissolved, there must be equal or less solute than there is solvent. We can use the amount of salt and water to determine whether a solution is unsaturated, saturated, or supersaturated. If a solution has more solute than the solvent can dissolve, the solution is supersaturated. If the solution has just as much solute as the solvent can dissolve, the solution is saturated. If a solution could have more solute added to be dissolved, the solution is unsaturated. The recorded value for a saturated solution of salt and water is 36 grams of salt per 100 milliliters of water, or 0.36 grams of salt per milliliter of water. In the first class, we added 1 tablespoon of salt. This was around 17 grams of salt. To this, we added a tablespoon of water. A tablespoon of water is 15 milliliters. This created a ratio of 17 grams of salt to 15 milliliters of water. This would be equivalent to 1.13 grams of salt per milliliter of water. Since this is larger than the saturation point of 0.36 grams of salt per milliliter of water, we know this sample is supersaturated. This is why the salt couldn't be dissolved. There was too much salt and too little water. The second glass had a tablespoon of salt and 3 tablespoons of water. This means we added around 45 milliliters of water. So when you divide 17 grams of salt by 45 milliliters of water, you get around 0.37 grams of salt per milliliter of water. Because of this, we can say that the sample is saturated, because 0.37 is close enough to the recorded saturation at 0.36 grams of salt per milliliter of water. All of the salt will be dissolved and no more can be. In the last glass, we added a tablespoon of salt and 5 tablespoons of water. 5 tablespoons of water is the same as 75 milliliters of water. When you divide the 17 grams of salt in a tablespoon by the 75 milliliters of water and 5 tablespoons, you get a result of 0.23 grams of salt per milliliter of water. Since 0.23 is less than 0.36, we can say that this solution is unsaturated. This means that more salt could be dissolved if we wanted to add more.